Hi everyone, my name is Fallon Arvey, and today I'll be presenting the geology of Canyonlands National Park. Canyonlands is an incredible place where Earth's history is literally carved into the rocks. It's carved out by time, water, and the desert rocks. Let's explore how this park tells the story of both earth and water working together over millions of years. Alright, so Canyonlands is located in southeastern Utah. It's near Moab. And this park is famous for its dramatic mesas, arches, and of course its massive canyon systems. These features were all shaped by two major forces, the Colorado River and the Green River. For over millions of years, these rivers have carved down into the plateau, exposing layer after layer of ancient rock. So you can kind of see right there. That's where the river ran, and it carved out that canyon. And in order to understand how it carved out the canyon, we need to understand how the rivers got there in the first place and why they move the way that they do. So, about 70 million years ago, the entire Colorado Plateau was uplifted during the Laramide orogeny. And this uplift increased the elevation and steepness of the land, giving the rivers a much greater gradient due to gravity pulling on that water. It had a lot of extra energy, and the rivers were able to carve these canyons deeper and faster. And as these rivers carried the sand, silt, and gravel that they just eroded, the sediment worked like a natural sandpaper within the water flow, and it would scrape on the canyon walls on the banks of the river right there, which would grind down the rock even more. Seasonal flooding and differential erosion helped wear away the softer layers even more quickly, which shaped the mesas and cliffs that we see today. The Green and Colorado rivers are truly the lifeblood of Canyonlands. Together, these two rivers have eroded nearly 300 million years of geological history. Every canyon wall you see is essentially a cross-section or a look into the past from times when there were ancient oceans, vast sand dune deserts, marshlands, and everything in between. Without the power of these rivers, Canyonlands simply wouldn't exist. It would just be a flat desert. Now here, we're going to go into a really simple breakdown of the geological history of Canyonlands. So, the first step in forming Canyonlands was from the Permian through the Jurassic periods. This is when the layers of sedimentary rock were first deposited. And these sedimentary rocks, or just the sediment that formed these rocks over time, it came from rivers, floodplains, the sand dune deserts, and shallow seas. Once these were deposited, the Colorado Plateau was uplifted during the Laramide orogeny. And then finally, the erosion, due to the rivers being pulled on greater because of the uplifting, it carved out the canyons that we know today. And so the landscape you see is essentially the result of deposition, uplift, and erosion all working together. Now here you can kind of see a bunch of different layers within the rocks at Canyonlands. And some of these main formations that we see here are the Cutler Group, which formed from river and delta deposits in the Permian period. We also see Wingate sandstone, which was created from the ancient desert dunes. It's very similar to, well, I guess, most sandstone. And then there's the Cayenta Formation, which was formed in river and floodplain environments. And then you might remember the Cayenta and also the Navajo sandstone from the earlier videos in this course about Zion. And also, I think Bryce, both of them had the same sandstone. And basically, the Navajo sandstone is a representation of one of the largest ancient sand dune fields in Earth's history. And because of each of these layers were deposited differently, they have a sort of different chemical makeup. Therefore, it will basically change how hard the rock is, and therefore they erode at different rates. And that's why Canyonlands has so many different crazy features like cliffs and fins and towers, benches, arches, all kinds of stuff. Alright, and then, so here's where we can really see the way this river has carved out these two crazy U's. And we can see really just how powerful that erosion is over time. So, to reiterate, when the Colorado Plateau uplifted, these rivers became much steeper than they were before, even steeper than they are right now, which gave them the insane amount of power to carve these incredibly beautiful and steep canyons. But it wasn't just these rivers that shaped Canyonlands. It also had mechanical weathering, such as freeze-thaw cycles like we see in Bryce Canyon, where the water can get into the rock and then freeze, therefore wedging it apart. You got fluvial erosion from rivers, chemical weathering, where the rainwater can dissolve certain minerals within rocks. You have mass wasting, such as rock falls, when it becomes too unstable and they just all crumble at once. You also have aeolian or wind erosion. This area is pretty common to have pretty high winds. There's also crazy thunderstorms and flash floods, which can be very dangerous if you're hiking in there. And then jointing, where natural cracks in the rocks just guide how they break apart. And all of these work together to reshape this landscape. I also wanted to delve into some of the different districts of Canyonlands and some of the key formations that help it stand out among the many national parks in this state. Canyonlands is very often overlooked because it's somewhat out of the way. It's in eastern Utah, and most people just come up the freeway, they visit Zion and Bryce. But Canyonlands, it's often forgotten about. So I wanted to let it take the spotlight for a second and describe some of its popular spots and how they formed. So firstly, we have the Mesa Arch. It's a natural rock arch formed by erosion. And over time, the water, wind, gravity, it widened the cracks in the rock and removed the softer rock underneath, which creates the arch that we see today. Now, Upheaval Dome is one of the more mysterious features in Canyonlands, and it has two main theories for its creation. Scientists can't quite agree yet on what exactly formed it, but it's either an impact crater formed by a meteorite or a salt dome uplift, which was created when salt that was deep underground was pushed upward. Now, most recent research supports the impact theory because of how the rocks around the area show signs of shock metamorphism, but they still don't totally know. So, next up we have the Needles, which are very similar to the hoodoos we see in Bryce. It's just towering sandstone spires that were formed by the erosion of jointed sandstone. The joints create narrow cracks, and over time the wind, water, gravity, all kinds of erosion, they widen them into dramatic fins and spires. And then we have the maze. which is one of the most remote and complex canyon systems in the country. As you can see from this picture, it's absolutely insane. I bet I would get really lost in there. And it's just a network of these really beautiful and deeply eroded canyons with very thin ridges that was created by millions and millions of years of erosion along the natural fractures in the rock. Now, Canyonlands, it's very important to note that it is still alive and changing today. All of these same processes that formed it already are continuing to change the landscape and evolve it. We have river erosion, wind abrasion, flash flooding, weathering. All of it is still carving this landscape. Even though the changes are slow from a human perspective, this park continues to grow and change and evolve every year. Now, here are some of my personal pictures that I took on a flight over Canyonlands. I actually got to land at Canyonlands Airport, and it was the most beautiful flight I've ever had. And as you can see, I did fly over that famous W, I guess, a little figure 8 in the river. There were also some of these crazy, up in the corner, up here, you can see it was almost like giant cobblestone. I thought it was just really interesting, the way that it had been carved out. And so you can kind of see it from a macro perspective, from a plane, which I just think is really cool. Here are my references. They include publications from the Utah Geological Survey, National Park Service, NASA, USGS, and additional geological literature. So I hope you've enjoyed, and I hope you can go visit Canyonlands soon. It's definitely way worth it.